Transportation of respiratory gases, oxygen and carbon dioxide. So usually respiration happens in 4 stages: ventilatory stage, transportation stage, exchange stage and tissue stage. So in previous class we discussed about ventilatory phase, where oxygen and carbon dioxide are diffusing across. Oxygen from alveoli will enter into pulmonary capillary blood, and carbon dioxide in the pulmonary capillary blood diffuses across the respiratory membrane and enters into the alveoli. So now let us discuss about transportation of oxygen from lung to the tissue and carbon dioxide from tissues to the lung. So transportation of oxygen, usually oxygen that enters the pulmonary capillaries is transported to the tissues in two forms. So the first one is the dissolved form and the other one is a combined form. So dissolved form will carry about 3% of oxygen to the tissue, and in the combined form 97% of oxygen is carried to the tissues. So in the dissolved form, the arterial blood has got 0.3 ml of oxygen in 1 deciliter of blood, and the venous blood has got 0.12 ml of oxygen in 1 deciliter of blood. So totally 3% of oxygen is there in the dissolved form in our blood. So here, the overall in the dissolved form, the oxygen which is getting supplied to the tissue is about 0.17 ml. Means 0.17 ml of oxygen is supplied to the tissue in the dissolved form. So oxygen gets dissolved in the plasma in accordance with the Henry's law. So there is a law called as Henry's law. So as per this Henry's law, that is, concentration of gas in a liquid will be directly proportional to solubility of the gas as well as partial pressure of that gas. So here, suppose oxygen. So the oxygen concentration in the plasma is directly proportional to oxygen solubility in the plasma as well as partial pressure of oxygen in the blood. So depending on these two factors, so this 3%, whatever the calculation they have done, it is based on this Henry's law. So for example, to find out the amount of dissolved oxygen in the blood, if partial pressure of oxygen in the blood is 100 and solubility of oxygen is always 0.003. Now we have to multiply 100 into 0.003 and we will get 0.3. So which is in the arterial blood they had told 0.3 ml of oxygen is there in 1 deciliter of blood. So we will get this value in this form whenever partial pressure of oxygen is 100. So I'll repeat again. So as per Henry's law, concentration of gas in a liquid is directly proportional to solubility of the gas, and also it is directly proportional to the partial pressure of that gas. If it is oxygen, then concentration of oxygen in the liquid in the plasma is proportional to solubility of oxygen and is directly proportional to partial pressure of oxygen. So then coming to the combined form. Okay, so here oxygen is transported in the blood bound to the hemoglobin. So RBC has got hemoglobin within it. So here oxygen will be in combined form with the hemoglobin, where it is bonded with the hemoglobin and then it will be delivered to the tissue. So usually through the combined form, so like 19.5 ml of oxygen in 1 deciliter of arterial blood is there, and 15.1 ml of oxygen is there in 1 deciliter of venous blood. So totally through this combined form, so the amount of oxygen which is getting delivered to the tissues is about 5 ml. So now whatever the oxygen is entering from alveoli to the pulmonary capillary blood. Okay, so that blood has got 3% of oxygen in the dissolved form and 97% of oxygen in the combined form. Means, for example, if 100 molecules are entering from alveoli to the pulmonary capillary blood, then 3 molecules will get dissolved in the plasma and remaining 97 molecules are in combination with the hemoglobin. So in these two forms it will be carried to the tissue. So the partial pressure and composition of oxygen in the body, whatever is mentioned in this table, this we had already discussed in the previous class. Now 1 gram of hemoglobin has got oxygen carrying capacity of about 1.34 ml. Means 1 gram of hemoglobin can carry 1.34 ml of oxygen. This is the oxygen carrying capacity of the hemoglobin. For example, if my Hb level is 15 gram per deciliter, okay, if my Hb level is 15 gram per deciliter, then oxygen carrying capacity of my blood is, we have to multiply 15 into oxygen carrying capacity of 1 gram of hemoglobin, that is 1.34. So totally 20.1 ml per deciliter, means oxygen carrying capacity of my blood is 20.1 ml of oxygen in 1 deciliter of blood. Then coming to oxygenation of hemoglobin. So the process, whenever oxygen gets bonded to the hemoglobin, this particular process we call it as oxygenation of hemoglobin and not oxidation, because whenever we speak about oxygenation during that time, hemoglobin, whatever the hemoglobin is there in our RBC, so it has got a porphyrin ring, and within that porphyrin ring iron is there in Fe2 plus form. Okay, so this iron Fe2 plus form, whenever hemoglobin is undergoing oxygenation, it maintains its form, it doesn't change its form, it remains as it is. Whereas if we speak oxidation, during that time what happens, so this Fe2 plus will be converted to Fe3 plus if it is oxidation. Okay, so always don't get confused, oxygenation is different, oxidation is different. So normally in our blood there is oxygenation of hemoglobin and not oxidation. So suppose if oxidation happens, then during that time whatever the hemoglobin is there, we call it as methemoglobin, not oxygenated hemoglobin. Okay, so the hemoglobin molecule has got porphyrin ring, so which has got iron molecule in it, and now each hemoglobin molecule, okay, it can bind with 4 molecules of oxygen and finally forming oxyhemoglobin. So this hemoglobin, now we call it as oxygenated hemoglobin. The oxygen combines loosely and reversibly to hemoglobin molecule here. So in oxygenation process, whatever the combination is there, that is loose and reversible. Means whenever that hemoglobin reaches the tissue, if tissue requires oxygen, then easily it can give up that oxygen to the tissue. So the whatever the bond is there, that is loose and reversible. It is an effective system for transportation of oxygen from lung to the tissues. The process of oxygenation reaction takes place within 0.01 second. So for this entire process, whenever hemoglobin reaches the pulmonary capillary blood, okay, in that for oxygenation to happen, the time taken period is very less, that is about 0.01 second. Now, depending on its affinity and oxygen binding capacity, the hemoglobin has 2 forms which are interconvertible forms. One is taut form or T form, the other one is R form or the relaxed form. So now taut form is nothing but, so whenever blood is taken to the pulmonary capillary. So there usually before that blood has got lot of carbon dioxide within it. 2,3 biphosphoglycerate levels are high. During that time hemoglobin will not accept any oxygen molecule. Okay, so that particular period we call it as taut form. And now in the pulmonary capillary blood, once oxygen level in the alveoli is very high, then what happens, initially one molecule of oxygen will bind to it, and slowly whatever the binding was there with the 2,3 biphosphoglycerate before, that will be broken, and the affinity of hemoglobin to the oxygen will keep on increasing. Okay, so now whatever this affinity increases now, so where hemoglobin can take up with more and more oxygen molecule, that particular form we call it as relaxed form. Now coming to the saturation of hemoglobin.